Assalamualaikum and greeting for everyone. Today, me and my group will be present STA108 group report. So the title of our presentation today is the experiment to determine the acceleration by using the simple pendulum. Before we start our presentation, let me introduce you our member of this group. First of all, hi, my name is Nurfatin binti Jafar, and this is my friends Lelania Natalia, Alexandra Dudi, and Nur Shahira. First is the introduction. So, the background of this study, the analysis of fundamental harmonic motion is the study goal. This experiment will be conducted by 4 students using the lab equipment. The data become from the conclusion reached by 4 students that conducted this study. The UITM Cawangan Kota Kinabalu Komsat Physics Lab is where the data was kept. In order to meet this requirement of STA108, basic statistics and probability, this course was to organize according this semester, so we had to make decision of verge to acceleration using the simple pendulum. The focus of investigate would be the acceleration. The science say the oscillation happen faster and short the leg. Just in the order of this analysis acceleration in this study, we would to employ the simple pendulum. So for this objective, the objective for this study is to determine the acceleration by using the simple pendulum.
Hi, I'm Shaya. So for our methodology, we have 3 types: data description, the graphical technique, and the numerical technique. So for our data description in this study, we investigate the acceleration that using a simple pendulum based on the guidelines from an official physics handbook. So for this experiment, which is the involved of varying the thread length between 0.1 to 1.0 meters, and the recording the time taken for the 10 escalation with a digital stopwatch. And then the data will be collected, addressed to the lab manual's instruction, and the aiming is to demonstrate the principle of acceleration. So for our graphical technique, we have 2 variables, which is the variable x, the length, and the variable y, the period, the time of the escalation. And for the chart, we're using a scatter plot. And last is the numerical technique. So in this study, a various of statistical measures have been provided for the analysis between the relationship of the thread length and the time that required for the 10 escalation. The statistical measures have been included by the mean, median, the mode, the standard deviation, the variance, skewness, range, the lowest value and the maximum value, first quarter and the third quarter. So for the both regression and the correlation, we analyze are employed to demonstrate the link between the thread length and the time for the escalation. As for the correlation coefficient, the ranging between negative 1.0 to 1.0 to utilize is to quantify the strength and the direction of the relationship that between the 2 variables. A positive or the negative value of the correlation coefficient indicates the degree of the correlation, while for the regression analysis is focusing on the independent variable x and the independent variable y, and which is also discussed as a method to explore the linear relationship between the thread length and the escalation time.
Hi, I'm Alexandra and I'm going to talk about the result and interpretation. So the data that we have is in tabular technique, as you can see in the table, and second one is graphical technique. As you can see the graph, there is a simple scatter diagram. So based on IBM SSPS application, this is the descriptive statistic analysis that we get. First is the mean, the average. So the mean for length is 0.55. So it means that the average length used in the experiment is 0.55 meter. Meanwhile, the mean for period of oscillation is 14.992. So it means that the average period of oscillation in this experiment is 14.9920 seconds. Second one is mode, which is the higher frequency. From the data, multiple mode exists for both length and period of oscillation, for which the mode for length is 0.10 and 8.43 for period of oscillation. Third is we got the median, the value in the middle of the data set. The mean for length is 0.55, so it means the middle value of length in this experiment is 0.55 meter. Meanwhile, the median for period of oscillation is 15.4. So it means that the middle value for period of oscillation in this experiment is 15.4 seconds. So next is measure of position. From the statistic table, it shows that the percentile as the measure of position, not quartile, but it gives the same meaning, so we can take the data it is. The first quartile is the 25th percentile, meaning that 25 of the data below the first quartile. It has a value of 0.275 meter for length and 10.7375 seconds for period of oscillation. The value is the middle number between the minimum and median. The second quartile is the 50th percentile, meaning that 50% of the data falls below the second quartile. It has the value of 0.55 meter for length and 15.4 seconds for period of oscillation, which has the same values as the median. The third quartile is the 75th percentile, meaning that 75% of the data falls below the third quartile. It has the value of 0.825 meter for length and 18.9275 seconds for period of oscillation, which is the value of the middle number between median and maximum. Next is statistical dispersion, which is the variance and standard deviation. The variance for length is 0.092. It means that the value of the data set is relatively close to the mean, with a small amount of variability or spread around it. The variance of 0.092 represents the average square deviation of the data points from the mean. Since the variance is in a square measure, it is not the original units of the data, making it difficult to interpret directly. However, the square root of the variance, known as the standard deviation, provides a more intuitive measure of dispersion. In this case, the standard deviation is 0.30277. The standard deviation represents the average distance between each data point and the mean. Since the standard deviation is relatively small, it suggests that the value in the dataset are closely clustered around the mean of 0.55. In summary, the data exhibit a low degree of dispersion with value closely clustered around the mean, as indicated by the variance of 0.6 and the mean of 0.55. So next, the variance for the period of oscillation is 19.1956. It means that the value in the data set are more spread around or dispersed around the mean compared to the previous example. The variance of 19.1956 indicates the average square deviation for each point from the mean. Meanwhile, the variance itself is not the original units of the data and can be difficult to interpret directly. The square root of the variance, which is the standard deviation, provides a more intuitive measure of dispersion. In this case, the standard deviation is 4.46725. The standard deviation represents the average distance between each data point and the mean. Since the standard deviation is relatively large, it suggests that value in the data sets are more widely dispersed and scattered around the mean of 14.9920. Summarize the variance of 19.1956 and mean of 14.9920 indicate that the data set has a higher level of dispersion compared to the previous example. The values are more spread out around the mean and indicating greater variability and inconsistency in the data. Next is skewness. The oscillation duration and period have skewness value of 0 and negative 0.124. A distribution degree of asymmetry is gauged by its skewness. When distribution skewness value is 0, it's considered entirely symmetrical, which means that neither is left or right skew affect its balance shape. A skewness of 0 indicates that the data is uniformly distributed around the original and The distribution mean, median, and mode are all equal. On the other hand, a skewness value of negative 0.124 suggests a slight negative skew. Negative skewness indicates that the tail of the distribution is skewed toward the left side. In other words, the distribution has a longer or flatter tail on the left side compared to the right side. The mean will be less than the median, and the majority of the data points are concentrated toward the right side of the distribution. So from the graph, we can see that the pattern of the intersecting points can graphically show relationship patterns. In this case, it shows a strong positive correlation. So next is correlation. As the table suggests, the Pearson product moment correlation for length and period of oscillation correlated to each other gives the value of 0.997. This value signifies a perfect and positive relationship between them. Next, model summary. This high value indicates that the model is able to provide a highly accurate prediction or explanation of the period of oscillation as dependent variable by using the length as independent variable. The model summary table shows that the coefficient determination value is between 0.993. This means that 99.3% of total variation in the regression equation can explain the model fits the data very well, capturing a large portion of the variation.
Next is conclusion. Based on the data that we have interpreted, we can therefore conclude that the oscillation time rises in proportion to the string length. As the table is to illustrate, the T grow along with the string length. This demonstrates how the simple harmonic ocean experiment fits Galileo equation. The last one is reference. This is our reference for our report. Thank you for watching and listening our presentation. Bye-bye.